All right. How's it going? Hope everybody had a good flight and all that to get here. This is Arc on iOS, coding and design tips for truly unreal success on mobile. So just to kind of give you a framework, I'm Thomas Williamson. I'm the final boss, CEO, whatever you want to call it, at Ordrum Studios. We've been porting games to mobile mostly for the past 12 years. We started off on the App Store right when it came out and ended up working with a lot of really good IPs, essentially down porting and up porting based on what the original content was. So we're really known for difficult technical projects with interesting design problems. Some of these games, like when GTA 3 came out, that was probably kind of a landmark game for mobile devices just because people didn't expect to be able to see that early. In 2011 is when that came out. But since then, obviously, we've worked with a lot of the Rockstar IPs. They trusted us since that went well. We've got some of our own original stuff with Orlux, which has got a few million players. But now we're known for Arc on iOS. Arc on mobile is kind of a massive undertaking. The original game has probably around 200 to 300 man-years of dev behind it, just in terms of the actual scale. The game's got about 25,000 dinos that are of like about 100 different species that have their own ecosystems on the island and have a lot of systems in use to scale that across a 50 square kilometer island that's pretty articulately designed to have different biomes and different areas. Then this is all simulated on a server, and these servers are persistent instances where players can log in and log out and have their own bases and tamed dinos that they plan to keep forever. So we've got thousands of those servers in order to maintain that sort of infrastructure. And so far it's been pretty successful. We've got 10 million plus downloads, 300,000 or so daily active users for the game. And those users, of the ones that pay, we have about a $20 average revenue. So it's been very successful, and everybody's been happy with the project. And we've clearly have turned this into a live service game that we'll be maintaining. So just to kind of give you an overview, this is going to be a pretty high-level talk. I'm going to try to do a weird combination of going over probably our biggest problems at a high level, and then drill down into some very specific things that we did to make this work. But feel free to talk to me later if you want any specific information, and I'm going to try to make sure we have room for questions. First I'll talk about the touchscreen. The touchscreen is awesome. A lot of people give the touchscreen flack, but in reality, you've got 10 simultaneous possible pointers with varying pressure that you can measure. You have deltas that come in many times per frame. Usually this is sub-millisecond accuracy, so you can do really interesting things with gestures. And then the fingers themselves, as biomechanical system, is actually probably the most precise, sensitive type of input you can get from a user. So touchscreen is really awesome, and just wanted to avoid having any sort of stigma. But then the touchscreen, it's also terrible. The touchscreen is probably the worst way you could play a game. There's no tactile feedback whatsoever. So if you are trying to, for instance, look where your finger, or know what your fingers are touching, you're going to have no concept of that whatsoever because you cannot see them over your fingers, and that requires concentrating your sight elsewhere. And that's really the fundamental problem behind a touchscreen. So when people talk about touchscreen controls, they usually go into vague things that aren't very specific. They're just like, I can't stand controlling this game, and I don't know why. The reason why is because they have to avert their awareness to a different part of the screen rather than from the gameplay. So when you're designing a touchscreen game, and this is probably the #1 design question whenever you're designing something from console or PC to mobile, is you need to think about what aspects of your gameplay loop are most important to you, and then use that information to keep as many touch elements out of the active gameplay screen as possible. And what I'll do is I'll just kind of go into how we did that for Arc Mobile. It's going to be pretty specific for your game, though, how you actually answer this question. So our 3 important things for our gameplay loop were exploration. We want players to be able to explore this whole island with all these different creatures. Navigation around that island, so they need to know where they are pretty easily. And then defense. They need to be able to, if they get attacked by like a raptor or a T-Rex, be able to quickly defend themselves, because probably the worst feeling in the world in most games is loss. So how did we go about doing that without making sure that they had to avert their gaze? So the first thing we did is we divided the screen in two, and that's because you have two hands usually. And the left side of the screen is used for movement, just like you would with an analog stick. But for us, it was just, press. If you press down, that's it. You don't have to move your finger at all. It just moves the player forward. After about a half second, it'll start to increase their pace, so you don't even have to do anything. You just press, and then it'll walk and then run. And then if you want to strafe, you just go, left, right, or down. And that might seem like that would be bad because you'd start moving forward immediately, and then you'd go backwards, or you might start moving forward and then immediately start strafing left. But like I said, we actually have sub-millisecond accuracy on these touchscreens, so you can know that they're swiping left very, very quickly and avoid anything like that happening for the player. Then the right side of the screen is really just a mouse. If you touch and move around anywhere, you'll just go left, go right, go up, and that's just a camera. What that's convenient for then is a single tap or a double tap can then do context-sensitive actions. So if you're about to face a raptor or a dino or something and you're on that, you tap on the right side of the screen, that's reserved for attack. And then similarly, if you're going up to a bag of stuff to look at, it'll open up the inventory, etc. And then, because we want to keep their gaze centrally located, we put all the info about what they're looking at in the top of the screen. This, in the original game, this was like right on top of what you were looking at because it was easy to move around, but it's not on touchscreen, so we put it up there. And then we put those context-sensitive, immersion breaking buttons in the upper left side of the screen, and those are things that are used very rarely. So our mantra was we just wanted to get 95% of the gameplay loop in this area where you just didn't have to touch or look anywhere other than just instinctively using your fingers. Bears mentioned that how do you switch weapons? That's swiping in from the right side of the screen, so they would just swipe in, and then they'd be able to get these weapons. And this is actually a fun way to do this because since you have a one-dimensional array of inventory, we can actually provide tactile feedback with the phone's vibrate control, so you can know when you're switching between each individual item when you swipe in from the right. And then, of course, there's another side of the screen, so swiping in from the left does things like crouch, switch camera, things like that. So that's how we designed the in-game stuff. And then we have an inventory menu that's really involved. There's all sorts of stuff that you can craft and stuff that you can apply. You can apply stats. You can look at individual statistics for individual tames. You can go through the quest system. All this stuff goes through this inventory screen. And so what we endeavored to do with this is just make it feel familiar to the player. We gave it a mobile-centric feel. So we have swiping between views, which is similar to switching between apps. Just tapping on anything it had a context window somewhere in the inventory that would tell you what you were tapping on. Holding and dragging, just like you would do apps in the home screen, was used anywhere in the inventory where that was applicable. And then we had a quick double tap to use stuff, which is sort of common. It just depends on the context. And so we did all that, and then we immediately implemented from our previous experience as many options as possible. And then what I say, be more like PC here, is I'm like in PC, people can use ionize and set up all these configurable inputs, and I recommend doing the same thing on mobile. So in general, design your best experience. When you're thinking about options, just make all the defaults what you think is the best way to play the game possible, and then completely disobey your mantra with options. Even if you think that it's terrible for the player's experience, just if you know that it's a popular way that other games are played, you have a lot of obviously inputs you can use from all the different apps on the App Store to see how they do things. Make it an option. It's not going to really ruin anything for the player unless they go in and toggle it accidentally. And that's like a giant list of all the options we added. We had all sorts of stuff like on-screen buttons that we think are terrible ideas and all that stuff, but every single time we added something like that, we had a few more happy users. Okay, so that's touchscreen. That's all I'm going to talk about for touchscreen. Now I'm going to move on to some more of the technical stuff we did to scale this down. Just to give you a kind of an idea of how we had to scale this down, our target min spec on iOS and Android really was the iPhone 7. It has about 1 gigabyte of actual usable RAM. This is the CPU score. I put score in quotes, and I'll go over that in a second. We wanted to target a 25 FPS standard, and then that's how many texels you can push per second. And then the min specs on PC for the original PC game was this Core i5-2400 with a 670. It's got 8 gigs of RAM, of which more than 8 are usable because of virtual memory. That's the Geekbench score for that CPU. And I wanted to talk about this because it seems like these numbers are close, but this number right here is actually what a phone that's at absolute 0 degrees that had just been booted up would score with Geekbench. If you actually run the phone for just even a few minutes, it'll be lower than this. And if you run a game for 10 to 20 minutes, you'll end up having something like 40% of that. So the real CPU specs are about a third of what we got on PC. I have no idea what the target FPS on the PC version was for the min specs, but I guarantee it wasn't 25. And then the amount that GPU can push is about 10x the number of pixels. So there's a lot to scale down. We got to scale down our rendering by 10x. We got to scale down most of our CPU usage by at least 3, and we've got to scale down our memory by 8. So the first thing to consider is the hardware itself, and so I wanted to go over just how a tiled renderer works for a second. So the tiled renderer is probably the biggest major difference these hardware platforms have over PC or console. The PC will just render the entire render target all at once, whereas on a mobile GPU, they want to render the scene to a single tiny piece at a time. And the reason for that is the mobile GPU has memory on the chip itself for the target colors, and that's because it uses a lot of battery to move colors to a render target, and they don't want to just rewrite to a render target over and over and over again that's external from the GPU. So they have this instead on chip memory that's then patched together later for the full target. And so that means that your whole scene is rendering for each individual tile. Every single vertex has to pass through each individual tile. And there are some optimizations they do to avoid some of that, but it's not very good. And this is just something you have to consider, is that if this was 12 tiles, which is actually a pretty small render target, you'd end up having to render the scene technically from a GPU throughput standpoint 12 times as many vertices, 12 times as many draw calls. And this, essentially, is why high-end games are hard on mobile. So let's complement that target hardware. So the ways we did that is we lowered the draw calls. The foliage was just halved across the map. Landscape verts were, I think we ended up going like 3 LODs lower. They had a really, really dense landscape. We heavily used SimplyGun. This is kind of across the board. Most of our meshes were somewhere between 5 to 10%, I think, of the original. We did a full material rethink, so our shaders are all custom written for mobile. About less than 50 total materials. I put a raptor head next to this, so you'll see this around the presentation, just talking about specifically what items I think are really hard. So this requires you to touch all content, including textures usually, if you do a full material rethink. So be aware of that. And if you've got kind of a game that doesn't have the scale, you probably won't have to do it. And then we went dynamic lighting only with the pseudo last-gen PBR model. The reason why I highlight this is because we just completely changed how reflections work across the entire game, and that was a lot of low-level base pass shader changes. And the reason for that is also just to simplify things. No reflection captures meant a lot more performance. And then reducing memory was our next big thing. So we can target the target hardware with that stuff pretty well, but then we still haven't really reduced memory other than vertices. So we switched the whole terrain to level streaming. And that has a raptor head mostly just because to get that working well on mobile was hard. And there'll be more about that in a second. We removed all dynamic texture usage. The game had all these custom painting that you could do on creatures and on signs, and we just removed that because it completely gave the power of how much RAM was being used to the user. We stripped all GPU particle simulation. That included code changes to destroy all the render targets that it used, all that stuff. GPU simulation for the particles has a lot of buffers, and if you only have a gig to work with, it just doesn't make sense if you're really trying to keep things down. Natively, the engine uses PVRTC4. It's the 4-bit version of the texture compression that iOS likes to use. It's a pretty good-looking texture compression. It's probably slightly better than DXT1. But they do have support for a 2-bit, and really that's just about going into the engine code and switching the 4 to a 2 based on a flag. We ended up doing that a lot because at a high resolution, PVRTC2 looks better than a halved resolution of PVRTC4, but you have to gave us a little bit more flexibility. And then the game itself is actually Vulkan only on Android, which I'll talk about a little bit in a second, but Because it's Vulkan only, ASTC is guaranteed to work on whatever platform we were targeting, so we removed all other texture compression formats on Android. And that saved us a lot of actual, not necessarily onboard memory, but the actual storage size of the game. But if you want to learn more about this, all of the stuff that I just mentioned in the last 2 slides, I said I'd get to it. That was a lie. Morgan's actually going to get to it in about an hour in room 1, where she's going to talk about content reduction specifically for those things. We've only reduced a 100 gigabyte game to 2 gigabytes. It still doesn't actually fit in RAM. So we've got more to do. So one of the things we did is we changed the content model entirely. There was all sorts of stuff that was statically referencing Dino classes by their asset. So we changed that to soft references. So if you're in an earlier version of UE4, that's a T-asset pointer. It's a soft object pointer now. And that meant that we needed to have some stream ahead. So if we know that a particular dyno is 200 meters away and it's about to be turned on, we make sure we go ahead and stream it in and hard reference it somewhere. And by somewhere, I would mean an asset manager. So we added a global asset manager class that kept track of what needed to be loaded and what wasn't. And that's actually really useful, because then you have a known list of every asset if you're using this content model. And that allows you to unload those assets if the OS tells you that it's running out of memory, which is something that it will do on mobile. And then the other thing to mention about this approach is it's actually backwards compatible. So if you use a lot of soft references and you want to never stream stuff in for PC or console or something like that, just load them. There's no reason that doesn't work. Okay, we also reduced sounds enormously. This is a pretty easy slide. Just the variance, 10 footprints down to 2. Reduce the sound quality and sound length. We went from 256 kbps to 128. Sound is usually not that important on mobile. It sucks for my sound guy, but in reality, nobody uses it. There's a few people who will put on headphones and enjoy it, but it's probably less than 10% of the users. And we moved a lot of our sounds to stream in real time. That's got a Raptor head on it, just because on mobile, the engine's just not built to stream a lot of sounds. We had a lot of stability fixes with that. But we're still not there. We still needed probably another 200 or 300 megs. We ended up doing some crazier stuff that I wouldn't necessarily recommend. We disabled texture streaming. Because of our content model, this worked really well. We did an A/B comparison, and we got like 50 megs, because the buffers at their minimum for texture streaming were still just extra buffers that weren't really in use. We did some per actor memory reduction. So every Blueprint actor has a core scene component that you then attach stuff to it. But a lot of our actors were just sitting there on the island as just one static mesh, stuff like that. So we knew those cases, and so we went in and just removed those components in real time. If the static mesh component had no transform to the root component and we knew that it wasn't going to move because it was set as static, we just got rid of the component after it was placed. Our world save took up multiple megabytes of on-memory buffer. And the way that iOS and Android work is if you try to allocate memory and it doesn't have the memory, it'll just crash. And so if you have something that suddenly takes up 5 to 10 megs, it causes a lot of issues. So this particular case, we ended up writing the save to disk as we went, just changed how that archive worked. And then we used Landscape LD1 for collision, which saved about 20 megs, but our IK suffered for that. So that's, again, that really depends on your scale. If you're really trying to fit a lot on a mobile device, that's something that you can do. Okay, so we've done all the memory reduction. The game fits, but it runs at 3 FPS. So we've just done all that stuff, and we still don't fit. So how do we reduce the CPU? So the first thing to start with any game is really what game concessions are possible that makes people remember that this is the game that they have on PC console, what doesn't actually affect how much they enjoy it. So we have, I think in the original game, the creatures did come in around 200 meters, so we reduced that to 100. Having that distance quartered the number of creatures simulating at once. We limited the building height so that the actual bases that they built could only be so high. We found on PC and console that most servers had about 60 players on it, so we just set that to the cap to reduce our edge case issues. And then we introduced exploratory game systems, which may seem like it doesn't save CPU, but if the players all stay in one place and build up all of these dinos in this huge base and aren't incentivized to go out and explore, they'll just always have a bad frame rate. We did a lot of scalability work, so that involves, well, first and foremost, we went metal and Vulkan only. OpenGL just does not run fast. It is what it is. And so that involved going on to hundreds of different devices, trying out what defaults had good FPSs for them, figuring out good defaults for our scalability, and that involved mostly at what point do LODs come in, at what point do we turn off clutter, at what point do we not stream in our far LOD maps, things like that. So those are all the sorts of things that are affected by scalability, as well as we added like a special material for screen space AO that's not typically supported on mobile that we turned off unless they were on high or Epic. And then something to watch out for is you could balance all of this stuff. You get a great FPS, and then on iPad, for instance, and this is just something that comes with mobile, Apple decided with 12.2, I think, of iOS, that if you took up more than 85% of the CPU, meaning you were using both threads, or both of their hardware cores, more than 85%, it'll boot the game. They'll just say, no, you're using too much CPU, we don't like you. So we ended up, tuning it, and then we ended up having crashes for that reason. So you have to be careful, and honestly, it's probably a good idea not to use all the CPU anyway. And then we had some more tricky things that we did, which is hence the Ninja. We did a complete rewrite of the character movement to use async traces. That's got a raptor head on it for obvious reasons. Their character movement component is a lot of code. But what that did is if you've got a bird or a little or something small walking on the ground, you only really need one trace per frame for those to move realistically on mobile. And changing that to do a trace on a different thread, not in the middle of the game loop, helped tremendously. Off-screen optimizations are obvious. If something's not on screen, you don't have to take it every frame. Same thing with animations. Put your IK through a check, then make sure it's not on screen. You have no reason at all to check where a footfall should go if it's not on screen. And then special engine optimizations, trade secret type things that I can't talk about, hence the Ninja. Okay, so that's optimizations in a nutshell. Don't really want to go too much further because I want to make sure I have enough time to talk about some of the other stuff. Again, though, I ran through that really fast. If you have any questions about any specific thing, we'll have time for that, and you can always catch me later in the conference. Okay, so I want to talk about community management. Mobile, even if you are making a game that feels like a one-and-done game that you're just going to ship it and it's single player and no one ever is going to need to play with other people or have any sort of community, you're wrong. Pretty much every mobile game, if it's going to be successful, is going to be a live service game in some capacity. So take what I say about community management and maybe scale it down. But we really did have to have, for our game, which involves thousands of servers and lots of players that interact, a little bit more than that. So we ended up having 3 full-time community managers, or CMs, I'll call them that for the rest of this, that covered 72 hours a week for gameplay issues. I recommend you find passionate people, either for your genre, if it's a new game, or for your game, if it's not a new game. Make sure they have experience with social media. That involves usually someone who's ran a Discord server, someone who's been an influencer or tried to be an influencer but has a lot of technical skills. That's the sort of stuff you need for community management. You'll know if they do a good job pretty quickly. And what this leads to, though, for your game is amazing feedback. So we've got a really good review score average. We've got a lot of interaction on our social media channels, millions of views, lots of likes. I don't know, I think one of my community, the guy who put this slide together, I think picked some random things. But there's a lot of good stuff that we get from our community management in terms of community response to it. They know that we care. And if you want that to succeed, that means that you want these people who are interacting with your player to have some sort of integration into your app, whether that's really cool in-game news that they have access to and can change on the fly, direct access to the storefront. So our guys will put in sale items, featured items. They'll do promos, giveaways. That you want to have a reporting system that's easy for them to use. So we have a camera in game, and they can take the camera and hit a button, and it'll send an email with what they're looking at and their coordinates and their server and the recent chat for that server all in one email that they can just, they don't even have to say anything. If they see something that's obviously a player cheating, it's very quick for it to get to them right from the game. Make sure that they can feature stuff. So we have featured servers that players are doing a really good job on or doing fun stuff on, featured items, and then featured players themselves from time to time. And then contest integration. So if you want to have something like, we have a lot of our contests are based on making the prettiest looking base or the prettiest looking trophy room or tame or something like that. Directly integrating things like showing off the contest and the results in the game will get you far. And then influencers are obviously the direction that marketing is heading. And what we've done is we've had our community managers themselves create a program that their community leaders in our game can join that gets them direct access to us. So they can ask us questions about what's coming up, and if we feel like we want to share it, we can. We give those people content drops early, so if we release new stuff that costs money, we just give it to them for free so they can show off those things in advance or right as an update happens. And what this ends up doing is these influencers actually end up turning into essentially mini community managers, because influencers tend to have a subset of your demographic as the people that are playing and enjoying their game within that scene. And so as the essentially person that they're going to for all of their game news and all of their features, they end up reporting things to you, giving those players really good feedback on their issues, and it ends up saving you money, as well as giving all of these influencers a way to feel more powerful and keep working with your game. And then just something to mention is by doing all of this, you end up making more money because the hype window is smaller. You have all of these influencers who are able to push up stuff that's new and exciting right as you update the game, which means that they're talking about it. And the smaller that window is from when something comes out to the people talking about it in the game, the larger the hype, and that volume is really what will escalate any of your sales. So let's talk about sales. So free-to-play is something that a lot of people want to avoid when they're making games for obvious reasons. There's moral gray areas. There's a lot to integrate. But it's just the market reality on mobile. Every single AAA publisher that I know of has moved to free-to-play at this point, especially for their future products. That means that you have to consider your target audience as well as your buyer net. And that's what I mean by that is what net do you cast out to pull in purchases, and how do those things differ? When you're working with something that's not free to play, you don't have to consider that difference. But for a game like this, we've got a lot of players who are not of age to buy something. So when we set up a purchase, we have to make sure that we have a responsible purchase that their parents might want to buy them, and how do we make sure that that is indicated to the parents even, that this is a good purchase for them and not some sort of scam. That tends to be a problem. So that's something to consider for every single mobile game you release. And then you have to consider the free-to-play infrastructure, which I'll talk about. So our buyers and our target audience happen to be everyone, because the game has PvE elements and PvP elements, and they tend to want to buy all sorts of different things. So all of our items cover the entire game in terms of what they can buy. PvE players can enjoy cosmetic features and time savers that they normally would have to grind for. PvP can quickly get back to where they were if they get raided. And then single player, we make sandbox items available that, some of the devs at my studio actually cringe at this one, but we just give them access to cheats and stuff like that in single player. And then you have to consider how you will monetize those purchases. We ended up using a very broad monetization targeting strategy, and that's really not for the faint of heart. That's why I put that in there. Most games will use one of these strategies, and that is, do you want to use ads to support monetizing your game? Do you want to use in-app purchases? Do you want to do a subscription and just have like an elite tier player? Or do you want to really focus on retention and avoid all of this, which is the sort of the Angry Birds strategy, where they came out with a game that had nothing and then started to monetize on follow-up titles and follow-up DLC. And then if you do end up doing anything, you're probably going to end up having a virtual currency. I would highly recommend tying whatever your currency is to the game lore. It's really obvious when a game has gold coins that are in the store and then you don't see them anywhere else. They don't have any gameplay way of getting them that makes any sense. So Mario actually did this really well on mobile because they have coins. We ended up introducing a new game item that was our virtual currency, and tying that literally into the game lore. Our Ancient Amber, which is what it's called, the players will actually find out that it has properties that are ancient that came from the special version of the island that they're on, and it's really important to make them feel like that stuff belongs. So then our subscription is something called Primal Pass. This has actually turned into a good piece of our revenue, so I figured I'd talk about it specifically. Mostly because, for me, the Primal Pass is the best option for monetization. If we could force our players to only buy one thing and not buy any of the other stuff, we'd have them buy the pass, because as game developers, the pass is what gives us the incentive to make the best product, rather than trying to come up with other ways to make money, which is really not what we want to focus on. So Our pass is $4 a month, $35 a year, so a heavy discount for a long-term subscription. It removes all the ads. It gives players access to exclusive servers. We do a monthly loot drop for them where they get more virtual currency and get special versions of items that are rare. There's bonuses if they do buy currency. So even if they have, if they have the pass and they go buy like 100 Amber, they get 110 Amber because they have the pass. And then this has worked out really well. We've given them all of this stuff, and we end up having about 15% of our DAU use the pass. So it's turning into a pretty significant piece of our revenue. So I thought I'd bring this up mostly because if you implement one piece of free-to-play and you're a traditional game developer and you want to go on mobile, this is probably your best option. Okay, so let's say you've implemented it. You've got exactly how you're going to design your free-to-play figured out. You have to go into implementation. You absolutely must do server-side verification of purchases. On both iOS and Android, there are very, very easy-to-use tools that just hack into the back end and pull a recent transaction and just send it in. And of course, your client-side verification is going to always work for that. So you have to have servers go in, use their easy JSON API, and it is very easy to use. It's just an HTTPS push and get. It's just a single command where you can send them a receipt and they will send you back the verification data for that receipt. Do that. It's worth it. You will literally lose 90% of your income if you don't do this. And then keep in mind that those receipts can get very large on Android. We've seen some of our test devices eclipse like 500 kilobytes. And I don't know why that is, but just compress it and send it to the server. And then make sure you handle traditional mirror attacks. And by that I mean the same thing I just mentioned. They'll get a valid receipt and send it to your client, or the client will send it to the server if they've hacked the client. But if you've seen that receipt before, then you know that it's not valid. So there's a really simple way to fix that one. And then when I say refresh receipt attacks, this is specifically on iOS. You can request any receipt be refreshed server side, so it'll look like it's a different receipt unless you use the correct IDs to check to make sure that it's not a duplicate or a mirror. So you have to actually do that yourself. You have to refresh your own receipts and then see what's the same so that you make sure that you're verifying the right pieces of the receipt. And the reason why I'm not getting into specifics about which one is because subscriptions and non-consumables and consumables all are kind of a little different, and it's not documented well. So you just kind of have to look at your real-world data and figure out, obviously, how you would try to hack that if you had full access to the game executable and to change it. All right, so let's just talk about post-mortem. After we've done all of these things, and this was essentially our strategy from the get-go, and it worked well, but after doing all of that, what would I have done differently with Arc Mobile, just so you don't have to? And the first thing is we didn't really allocate post-launch dev time, especially programmers, because we were pretty sure we were going to do a lot of content drops right after launch, but we ended up doing a lot of compatibility work. We ended up doing more optimizations in specific device subsets that tended to perform better than we thought. So just keep in mind that you want to probably have at least, even any game you should probably plan to do about 2 months of post-launch work on compatibility and performance. And then consider live QA iteration. What I mean by this is you want to have nice quality of life improvements for your devs while you're live. And that means things like how easily can they get call stacks for crashes on servers, clients, how easily can they determine statistics for what features are being used and what features are not being used. If you're doing a lot of servers like us, do you have a good back end where you can communicate with the servers and remote disable certain things if you need to? If you find out someone's cheating a lot with a specific item, being able to just remove that item temporarily from the game for a live service game can mean a lot. And then know your buyer ahead of time. So we released with Primal Pass that I mentioned first, and we've got good penetration on that, but it took a while for that to percolate, and we ended up having a lot of IAPs and ad strategies that we had to add in post-launch because we really underestimated our buyer. And specifically for Arc, everybody who bought the console PC game had very little interest in the mobile game. They already had a really good version of the game to play. So who's left is going to be the people who don't have consoles, or the people who don't have the $30 to pay for the game on PC and console. And when we consider those buyers, we realized that we had to do a lot more ad-based monetization, and we didn't do a good job of that. And so that's something you just want to kind of put yourself in the head of who's going to download this particular product on this particular SKU. And that's something we definitely could have done. So I want to thank you. This is kind of my final slide. Don't forget Morgan's talk. She will be talking about the content reduction a lot more in depth and go into specifics on what we did for types of content. You can add me on Twitter here. If you want my email or something like that, I'm happy to give it to you. Just ask me up here. I'm not going to put it on the slide. If you are interested in Arc Mobile and haven't played it, you can go ahead and download it. If you use this particular promo code, you can insert promo codes at the bottom of the store. You will get like $10 worth of free items if you want to try it out, and it'll help you get started. All right, I hope you enjoy the rest of your conference. Thanks, guys.